Welcome to Stationeers and dual axis solar tracking. So this one's going to be a bit of a short tutorial episode rather than a regular sort of playthrough, me commenting, because there's absolutely no way that I could possibly do this while actually talking to you guys. I would have to have done the work first. And you can see right now, as the sun is tracking overhead, the solar panel is turning, as well as going up. And you see, as the sun gets to its zenith, it is turning quite rapidly. All of these are just the old ones. That's our original cheap solution. So it's going to flip around. Okay. And we're about to hit this 391, 412, 411, 410, 90% efficiency. 89 versus 86. So it's slightly more efficient. It just needs a little bit more tweaking of the values, I think, to get more efficient still. But what's happening, you'll see, as it turns around, it's going to start going down again. Unlike these, it's not going from 0 to 180. The vertical axis is going from 0 to 90 and back to 0. Well, in fact, actually, it's going from 0 to 90 and back to 0. I need to change one of the values to actually make it a little bit better. I'll come into that in a little while. But you'll see now, it's now rotated 180 degrees, or nearly. And as the sun goes down, it's going to continue to follow it. And of course, aside from around noon, it's going to look a lot like these. But it isn't. So, a little bit more power, you see we're getting from it? Yeah. So, let's get started with not with math, but with the electronics. It does need a lot more electronics. This is what it needs so far. All we need to do to make all of them follow this is change these from logic to batch writers. That's it. And everything else will just work. Oh, and reconnect that one bit of cable. Okay. But I've left it like this because this is a good test case. You can easily see how much different they are during the day. We could graph it as well, but rough things up first. So let's get started. First, we need to change the way that these tilt. From 0, and that's Windows saying, hey, new version of Java. No. We need to change it from 0 to 180 on a single axis to 0 to 90. And that's what we're going to do first. Now, this is where things get a little bit mathy, but not too much. So instead of going from 0 to 180, what we want to happen is at 90 for it to reverse course. So if you imagine a straight line graph going up and to the right, halfway up, you want it to go sort of 90 degrees and down to the right. So sort of like an inverted V. Now, when you get graphs like that, that normally means the absolute function is happening. You know, when you have a bar each side of a value, straight vertical bar. So, for example, minus 90 becomes 90, 0 stays 0, 90 stays 90. It basically removes any negative numbers. Okay, so that's indicative of that kind of function. So let's get started with what we need to do that. We're going to take... Here we've got our vertical reader, and we're going to first of all subtract 90 from it, okay, because just the way things go, we need to move that straight line so that it's split directly by an axis. Okay, so moving it 90 down means it now goes between minus 90 and plus 90. Okay, next we're going to simply say absolute that. So instead of going minus 90 to plus 90, it's now going 90, 0, 90. So like a V shape. All right. Then we take that V shape and we multiply it by minus 1. And all that's going to do is flip it upside down. So now we've got the inverted V shape we want. It's just in the wrong place. And then finally, we just take that and we add 90 again. And that moves us back up to where we need. Because remember we took off 90 at the start? Well, once we've transformed it, we have to add 90 back to actually get everything working. Now, if someone can think of a more efficient way to do that, by all means. So what this produces then is a track for the vertical that goes from 0 to 90 in linear sort of speed, and then back to 0, again, linear speed. That might not be exactly linear, because people who do this with trigonometry may well end up with a sine or a cosine function of some kind. Yeah, by all means, if there's a better solution, happy to hear it. Again, that's no problem. So what happens is if we disconnect and turn this off and leave that, all that will happen is it will face me at dawn, and so will all of these. It will go up to point straight up, so will all of these. And these will continue on the other side, and this one will come back down to face me at dusk. So entirely wrong. But if we can rotate it, then it will be entirely right, which is what it's doing right now. Ish. Okay, so the difference, what I was saying is it's not quite right, is because right now it's set to mimic these. The only difference is that I think it is it's rotating at a certain sort of speed as it goes around, so it's getting a bit of efficiency there. So what we actually need to do is the final value we want for this needs to go from 0 to whatever you have in as the tilt in your world. So in my case, if the tilt is 8 degrees, I want it to go from 0 to 82 degrees. So instead of 0 to 90, 0 to 82, I stop 8 degrees short. So that's just something I need to take care of on my world. I'm not going to show you how to do that. It's obviously trivial, but you'll see that we'll have no real problem doing that. Okay, so that's the vertical side. The horizontal side is a bit more complicated, and if you thought that was complicated, yeah, this is going to take a bit more explaining. There is a bit of an issue halfway around. So just the way that panels like this work is that when it's pointing straight up, it needs to flip around pretty quickly. Unlike when it's close to the horizon. So the worst case is, for example, right here at 45 degrees. If I started turning this around towards me, and let's say it was pointing at me right now, 45 degrees is a quarter of the way through the daily cycle. So that means it would be, the sun would be 45 degrees up in the sky, but the panel would now be facing me. And it doesn't matter which way it goes vertically, it would still be facing me. So it's way off. So what we have to do is close to 0, i.e. close to when it's facing dawn. We have to not move it very much at all. And then when it gets really quite close to being pointed straight up, we have to sort of flip it around quick and then mirror the same thing on the other side. Go right into 0 again quite quickly, or close to 0, and then finish. All right? Now that function, it looks sort of like a normal distribution function. It's also called a Gaussian function. Oh no, no, sorry, it's not. No, it's not the normal distribution. That's something else I'm thinking of. Sorry, it's the logarithmic growth function. So it starts off at a very low value. Imagine the x-axis 0, and then as it approaches a certain value, it quickly jumps up and then goes asymptotic. It goes very close to the second value. That is sort of like a stretched out square wave. If you imagine it going from 0 straight up to 1 and then across very quickly, imagine that but stretched out and curved a bit, and you get the idea. Now there's a couple of values we can change to decide how quickly it transitions in the middle. And because I'm not doing this by trigonometry, I'm just doing it by like best fit, I can just play with that value. And there's only really one value you need to change. So once you've got this set up, it should be simple for you to play around with it. Because what's going to happen is on worlds, for example, are more tilted than this, you'll change this vertical value to 45 degrees instead of 90. So it won't get all the way up, pointed up. It will just get halfway up. And then what you'll want to do is make the transition much slower, i.e. not flipping around quite as much on the horizontal side. So let's go through the horizontal side, and hopefully you'll get the idea. If you don't, leave comments below in the comment box, and I'm more than happy to answer them. And of course, if you have better solutions, again, I will remind you that this is just best fit. It's not me working it out because, one, it's been a while since I did trig. Number two, even if I were to go and redo that, which I'm perfectly happy to do, I probably wouldn't have time to do it in a daily video format. It would take a couple of, well, because of the spare time I have while doing all these other videos, it might take me a few weeks just to brush up on the knowledge. So instead, we go with sort of common sense, and we'll see how close it gets. It seems to be good so far. So we take the vertical reader value. Remember, it's 0 to 180. And let's subtract 90 from it. Now, all that's really doing is it's just shifting the angle based on the way my solar panel is set up. Because mine is set to like -90 by default instead of 0, I've got to shift the value before I do anything to it, just so that everything lines up correctly. So if your world doesn't correspond to this properly, just change this value. So subtract from the vertical value. All right. Now we take that vertical value, minus 90, and we multiply it by minus 0.2. This is the one that everyone just go, what? Why minus 0.2? This is just a scaling factor for how long it takes to move from the low value to the high value. The bigger this is, in fact, hang on, this might actually be the smaller it is. I think it's, yeah, if it's smaller, I think it'll actually take longer to transition. So, for example, -2, -3 should be quite a slow transition, I think, if I've got the right way around. If not, then obviously you can play with it. But I think you want to keep it negative, if I remember correctly. Yes, you want to keep it negative. Okay. So we've got minus 0.2 here. And a feature suggestion, if anyone from Rocketworks is actually watching, could we possibly have it so that if I don't label this and I just set it to a value, you change the label to inherit the value? Because most of the time, I'm happy to just navigate through this and see the values I can actually choose from a memory. I don't actually need to label it anything, really. I'm happy to just call it a value. In the math cases like this. In the cases where it should represent a constant of some kind, yeah, by all means, I can actually put that in. But at the moment, I've had to set this manually. Okay, so we've got this multiplication of minus 0.2. Then we're going to use the exp function, okay, on the unary math unit. And this is the thing that really generates the curve that we're actually looking for. So it's going to stay at low values, transition quite quickly, and then stay at high values. The output from that, we're going to take that and add 1. This is just part of the logarithmic growth function. I think this actually maybe craft the top of it or something like that. But we add 1. It doesn't much matter why. You can obviously look at the logarithmic function. I'll try and put a link in the description below to that. And then finally, for this case, not the general logarithmic function, but for this case, we then take 180 and divide it by this result. Okay. So we end up with another value, and you see that's changing. I'm not sure if it's a bug in the game or if it's just intentional, but when this value is very low, it seems to stop calculating it, and that may be on purpose, may not be. But we've got this value. And then, finally, what we actually just want to do is subtract 90. And in fact, hang on, it may be that value you need to change, not this one. I'm not sure. We can actually try it as soon as the sun comes up, actually. I'll just double test which one it actually is, because I've put 90 in twice, and I need to double check which one it is that actually finally transforms it. But after that comes out of here, we just write it to the horizontal solar panel setting. And you'll see it looks fine. It's sort of working the same way that the others do, you know. That's no problem whatsoever. So we've got something that works relatively well. In fact, it works better than the others. However, of course, we are using 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 powered chips, 14 including the reader. I'm reusing this this reader up here, that one. And that is pretty much it, I think. Do I have anything else on this side? I seem to remember there being an odd value in here that I need to deal with somehow. Ah, yes, it's this one. So back onto the vertical axis. We're doing the same thing as we have down here. So I can take these chips out once I change over all of them. Remember, we're taking the value and we're dividing it by 1.8. All right. Now, 1.8 gives us that final 0 to 50%, which is what it would be if it passes straight overhead, 0 to 50, because we can't input degrees into this thing. We can only input percentage. Okay, so if that's 1.8, and you'll see its actual state is its label is 1.639. The only thing that's 1.639 is that is just the multiple of 1.8 with the, I think it's 91% for my world, for the 8 degrees of vertical. So I want to go, 90% of up essentially. So let's just grab my tool and just set that back to its actual value. Whoops. Set 1.6399999999. Okay. And the reason why I set that to 1.8 is because I was just testing vertical axis on its own, and that didn't produce the right value. Okay, so we can leave it to 1.8. There'll be no problem doing that, but let's see if this is any better now that's set to its proper value, i.e. 8% off vertical. All right, hopefully that's relatively clear. I know there's a lot of stuff with this horizontal that may not be obvious, and it's very hard for me to make it obvious, but the general formula is 100... High pressure? Okay. The general formula is 180, for our case, we're moving between 0 and 180. 180 divided by 1 plus the exp of minus 0.2, and then in brackets, x minus 90. Yeah, I know, it's a lot of math. But it seems to work, certainly for me on Mars, and you feel free to just copy it if you want to for Mars. Don't worry about actually setting it up or anything like that. We could do with a third-party website that would actually just let you model and share designs, and I could just share a link to it. That would be cool. I don't want to share the whole world just because it's on my personal account, not my Gradaster account, which is slightly annoying. I need to buy the game again at some point. But let me just cut forward then, and let's see how well this does. So it's not as good at the moment, and this is one of the slight downsides with changing that value, because close to sunset, it's different. Okay, so let's skip forward a little, and let's see if it gets more efficient than the others as it actually gets closer to noon. Oh, and one other thing, if you really wanted to solve this, you would also have to deal with the difference between what is 0% on these, which is around 15 degrees above the horizon, and the rest. And that's a different thing I did in season 1 that you'd have to append to the, well, actually probably pre-pen to this. You probably need to put it first down here somewhere to transform the angle probably between 15 and 165 or something like that, rather than what it is at the moment. And you'd take that and there's an input into the rest. I've done that in season 1. I'm not going to do it again just because it's again another set of lots of chips that don't matter terribly to start off with, but will matter more later on. So that's just something to account for. So 83%, 79%. So it's lagging behind because it's tipping upwards slightly too much by comparison to the rest. So again, that may be just a whole deal with it not being linear. So I may have to change that back to 1.8. So let's just, shall we just change that back for now? And I'll do some more investigation as far as what that should be. Okay. So as you can see now, it's actually more efficient, but it's not going to stop at, obviously, right near the peak. It's going to continue to go to 90 degrees like all the rest. So I may actually need to supply to do 2 different transformations here. 1 divided by 1.8, and then, I don't know, to lock it to its maximum. So it proceeds at the same rate as the rest do, but hit a maximum value. And then it'll stop there rather than anything else. And I think that will work just fine. It just means adding a couple more chips. So yeah, unfortunately that means more chips, but we get the general principle. We've got this rotation, which is only happening very, very slowly right now. And if should I just change? Yeah, we need to change that value to test it, don't we? So let's change the 0.2 value. Where are you? You're around here somewhere. So if I change this to say, I don't know, we want to change this to be closer to 0, I imagine. So let's just try 0.05, okay? And let's see how that affects it. I think that's already transitioning. Yeah, so the closer to 0 get, the more it changes sooner. So if you want it to change very quickly, make this value lower, i.e. 0.1, minus 0, -1, -2, etc. And it'll change very fast, but only near 90 degrees. So in our case, I'm just going to change that back to, I don't know, 0.1. And I need to do a bit of testing to see how slow that is now. But 91% versus 86%. But again, only around noon. And yeah, it's pretty good though. And here's the challenge. Can you do better? Can you do better with this particular logarithmic curve? Can you calculate what it should be? Or is it wrong entirely? Do we have to redo both to be in terms of sine, cosine, tangent, etc.? Or inverse x squared curves or x cubed curve? No, not x cubed, x squared curves, stuff like that. We can certainly do. There's no problem doing it. It's just that I don't know quite whether you're interested in that level of detail. In any case, let me know in the comments. No problem with that. All right, so that's pretty much this episode. I know it's been a bit tutorial and a bit explainy. Hopefully it's clear. Let me know in the comments if it isn't, and I'd be happy to explain further. I'll put a link to the description to a logarithmic curve, logarithmic growth function, I should say, and you can take it from there. I don't want to cover pretty much any of the normal updates that I would do in a regular playthrough, just because this is just about that. I'm getting it roughly up and working. And now I can change them to batch readers and batch writers or something along those lines and clean everything up and stuff like that. But for now, thanks very much for watching. As always, guys, feel free to like, subscribe, and share, especially share with mathematicians. I'm sure they'll find a better way of doing it. Using a lot less chips, hopefully. I did get a comment from one of the commenters just as I was recording this, actually. This is just recording just as the previous episode just comes out on YouTube, saying that there was a stream by Dean Hall, or Rocketworks at least. So go and watch that as well. I think they'll probably have a solution in terms of angles. If they do, that's great. From what I hear about it, they also used about 20 chips to do this. So this only becomes useful once you have a huge amount of solar panels, or where that sun is down here somewhere, because then this will just not work well at all. And in Europa, it's even less because the solar panels do not return enough power. So this is more of a general tutorial for all of you. You may not want to use it on Mars, perhaps, but hopefully it should be useful for you Europans. Yeah, attempt no landing there. All right, thanks a lot, guys. Thanks for watching.